This topic is about maximum power transfer. We can use the Thevenin and Theorem Norton to determine the maximum powers that a circuit can supply. So for example, this is the Thevenin equivalent circuit. So based on this Thevenin equivalent circuit, if we plot the power with respect to the resistance load, okay, so the power maximum is at the point where the resistor load is equal to the RTH. In the above circuit, the power that is delivered to the load RL is given by these equations. To determine the value of RL that maximize the power transfer from the source to the load, we can differentiate the power load with respect to the resistor load and equate it to 0. So this is power with respect to the resistance load graph. Okay, so the maximum power is at the point where the differential of the power with respect to RL is equal to 0. Okay, so we differentiate and equate it to 0, and we get the RL at this point is equal to the RTH. The condition that maximizes the power is when your resistance load is equal to your Thevenin resistor. The value of the maximum power is given by the power maximum is equal to the voltage Thevenin power of 2 divided by the total of RTH and RL power of 2 times by RL. So we can simplify our equations. We will get VTH power of 2 divided by 4RL. This is example 4.5. Find the value of RL for maximum power transfer in the network below. Find also the maximum power. Okay, so we want to find the maximum power at this RL. Okay, so for the first step, we need to remove our RL and then we redraw the circuit. Okay, so now our new circuit will be look like this. So this is your voltage source, 6 kilo ohm, 4 kilo ohm. So this is 3 kilo ohm, 2 milliampere. So this is where we want to find the VTH and also the RTH. Okay, and then for the second step is we want to find the RTH. Okay, in order to find the RTH, so we need to turn off all the independent source. Okay, so in this circuit, if we have a current source, we need to do an open circuit. If we have a voltage source, we need to do a short circuit. Okay, so we redraw again the circuit without independent source. We will have the equivalent circuit like this. So this is a current source. We need to do an open circuit. And then this is voltage source. We need to do a short circuit. Okay, so now the R Thevenin or R equivalent is C at this two node. Okay, from this view, we get the RTH is equal to this 4 kilo ohm is series with this 6 kilo ohm and 3 kilo ohm in parallel. Okay, so the RTH is equal to 4K plus 6K parallel with 3K. So here you will get the RTH is equal to 6 kilo ohm. And then for the third step is we want to find the VTH. We refer to the first step circuit. Okay, we will have our circuit now. It's like this. Okay, so we want to find the VTH at this point. So this is a positive and then this is a negative node. Okay, so in order to find this VTH, okay, we can by using this V1 and then this is as our V2. So our VTH will be equal to V1 plus V2. In order to find this V1 and V2, we need to find the current that flowed in this I1 and I2. So we can use the mesh analysis to find this I1 and I2. Okay, so at mesh 1, since we have a current source here, so and also this mesh is isolated, so our I1 is equal to 2 milliampere. Then we find our mesh 2 equations. We will get negative 3k I1 plus 6k plus 3k I2 plus 3 equal to 0. So we substitute this I1 equal to 2 milliampere in this equation. So I just rearrange the equation. I will get 9k I2 equal to, bring this one to right side, negative 3, and this one plus 3k I1 is 2 milli. So here I will get my I2 is equal to 1 over 3 milliampere. Okay, so now we want to find our V1. Since we already have our I1 and I2, we want to find V1. So from here, V1 is equal to 4K resistor times by I1, which is equal to 4K, times by 2 milli. We get our V1 is equal to 8 volt. And our V2 is equal to 6K times by I2, 6K times by 1 over 3 milliampere. So you will get this V2 is equal to 2 volt. So now our VTH is equal to 8 volt plus 2 volt, which is we get 10 volt. Okay, and then for the fourth steps is we draw the Thevenin equivalent circuit. Okay, so we have the VTH, the RTH, which is equal to 6 kilo ohm, and then our VTH is equal to 10 volt. Okay, and then this is where our RL. Okay, so in order to find a power is by using the IV equations, and we want to find power at this RL. So P is equal to I power of 2RL. Okay, so I is referred to this I current. So in order to find this I current is equal to voltage Thevenin divided by RTH and RL. RTH plus RL. Okay, so substitute this I into these equations. We will get P equal to VTH divided by RTH plus RL power of 2 times by RL. Okay, so at P max is when your RL is equal to RTH. Okay, so substitute this RTH into RL. We will get our P max is equal to VTH divided by, so this we change to RL, substitute the RL plus RL power of 2 times by RL. So we get the VTH power of 2 divided by 4RL. Okay, and then we substitute all the voltage we already determined and the RL. Okay, so VTH is equal to 10 volt power of 2 divided by 4 times by RL, which is equal to RTH. We get the 6K here. Okay, so then we will get 0.417 milliwatt 1.